Hello, my name is Warren Alexander of Group 13. Our group selected Jalbari village in eastern Nepal, and we had a couple main themes when coming up with solutions for issues. Our first theme is we wanted to do scale-based funding, and what we meant by that is for some issues we have not minor, but smaller solutions that the villagers could replicate or replace easily if they were to break. And for some things, we have larger purchases that the government would or a local charity would need to help fund. Another thing that we wanted to look at was non-intrusive solutions. And as I have on the slides there, that's a modernized, not westernized sort of mindset. Oftentimes, developing villages, when they get assistance, they kind of lose some of their culture, and we wanted to avoid that. Another thing that we wanted to look at was some of the things that we needed to solve we weren't given explicit issues for. So we decided to take some more like preventative measures with something like health instead of trying to solve a specific issue. We went for like sanitation to prevent problems from happening in the first place.
Hello, my name is Kaito, and I'll be addressing the thermal and water solutions for our village. In terms of thermal solution, we selected a rocket stove. We selected this option because rocket stoves are not very expensive, and rocket stoves are fairly safe and easy to use due to the design enclosing the open flame. The most significant benefits include technical, cooks food faster and more efficiently; environmental, uses less wood than open fire and clay cook stoves; economic, saves money in the long term; social, saves time for other tasks. The most significant risks include technical, smoking and firewood are dangerous to use indoors; social is not traditional; economic, this is a pretty big starting investment; and environmental, smoke and still using wood as fuel. The Sustainable Development Goals that this addresses are Goal 3, Good Health and Well-Being; Goal 7, Affordable and Clean Energy; and Goal 12, Responsible Consumption and Production. The types of engineers that this requires are mechanical engineers and manufacturing engineers. In terms of cost analysis, for fuel and the cook stove, for about 1 year, it's about $160, and about 5 people can use it, so it's about $32 per person. Okay, in terms of water solution, we selected the mineral pot water filter. This option is the most convenient for members of the Jalbari village because of the extreme usability and the fact that this water filter only requires service once per month and a new filter 2 times per year. The most significant benefits include technical, it effectively purifies water for human consumption; environmental, the system is made of environmentally friendly materials; economic, low-cost option for filtering water; and social, maintains traditional water collection methods. The most significant risks include technical, takes about 1 hour to purify 12 liters of water; social, must be refilled every hour and requires close supervision; economic, not a one-time purchase, requires maintenance; environmental, filters cannot be reused or recycled after use. In terms of Sustainable Development Goals, this addresses Goal 3, Good Health and Well-Being, and Goal 6, Clean Water and Sanitation. The types of engineers needed are mechanical engineers and chemical engineers. In terms of cost analysis, it's about $40 for 5 people per year, and that's including the cost of the filter and the cost of the unit. And so that's about $8 per person annually.
Hi, I'm Soneta. For the electricity, the team chose a solar panel called Mirigo. The goal is to provide electricity for the villager because this village usually got power cut, therefore having a consistent power source is important. The benefit of Mirigo are it lasts for 20 years and have cheap maintenance. The villager will be able to access to the electricity, and it's one of the cheapest solar panel. Also, using solar panel are good for the environment. The risks are it's not currently compatible with the grid. Need to put on a villager house roof, which can cause health problem. It has a high initial cost and maintenance throughout the years, and when it's broken, it will be thrown away in the landfill. It costs $900 per unit, and it requires $2 every month to access to the power. It serves 25 households per unit. The SDG goals are Goal 7, Affordable and Clean Energy; Goal 11, Sustainable City and Communities. The 2 engineers involved in this design are electrical engineers and mechanical engineers. Health. For how the team chose TFP composting toilet, the goal is to provide the waste management, allow the villager to have good health and sanitation, stop the spread of disease caused by unclean environment. The benefit of TFP toilet are it lasts for 10 years with no maintenance, provide proper human waste management for the villagers. It costs under $100 to learn and make it themselves. It can be also utilized for compost. The risks are there's still no plumbing or tap within the house. Villagers need to empty their toilets every 2 months, and it is expensive to buy one. To use the compost, the villager must dig a hole every 2 months. It costs $895 per unit. There is no extra cost for using it. It serves a household of 3 to 5 people. The SDG goals are Goal 3, good health and well-being. Goal 6, clean water and sanitation. The engineers involved in this design are environmental engineers and mechanical engineers.
Hi, my name is Elise Grossen and I'm presenting the Habitat and Transportation. For the habitat, we chose a better shelter, and the objective of the better shelter is to provide an appropriate option for emergency housing. Some of the benefits include the better shelter can house up to 5 people. It is very durable and long-lasting. Everyone in the village will be housed and out of harsh weather in times of crisis. It is cheaper than most shelters and lasts about 3 years. And the material it is made of are biodegradable. Some of the significant risks are transportation of the better shelter up to the village may be an issue because the roads are not very good. The shelter might be seen as strange or foreign. The shelters are not a permanent solution because they last only about 3 years. The shelter is very large, and a large quantity of them would not fit in the village because it is very small and it is on a very narrow road on a mountain. The cost analysis, price up front for the better shelter is about $1,260 USD. If it's about 5 people, lasts around 3 years. The maintenance, it's very basic maintenance. Replacement parts are available locally. The better shelter for sustainable development goals fits goal number 1, no poverty. Goal number 3, good health and well-being. Types of engineers that would work on this are architectural engineers and material engineers. For transportation, we chose the Mama Bird, which is a drone, and the objective of the Mama Bird is to look at different alternatives for transporting health supplies in small quantities. Significant benefits include it can travel about 60 kilometers and carry 10 to 20 kilograms. It helps in emergency situations for sure because the roads to our village are not very good. Drone services are really cheap, and drones run on electricity rather than gas, so they're environmentally friendly. Significant risks. In bad weather, that would mean no flying for the drone. It is a strange flying object, so it may be seen as foreign and it may be untrustworthy to people of the village. The drone needs to be based in a city close by. It cannot be based in the village, unfortunately. Overheating may lead to a crash, and that could cause a forest fire, so that is a risk that would be taken when using the drone services. When it comes to cost analysis, the kits vary in price, but the one that was listed, there is a birth kit and it's about $529 USD. The kits only serve one person. Maintenance and repair are filled by the company that it is based in the city. So there's no maintenance done by the people in the village. For sustainable development goals, if it's goal number 3, good health and well-being, and the types of engineers that work on this are mechanical engineers and software engineers. Thank you.
Hello, my name is Tang Tran. I'll be doing the conclusions. For further exploration of our problem, due to our problem as a bigger whole being really daunting, we had to focus on sections of the problem. For example, our electricity solution, we focused mainly on power creation, so that the village would have a reliable source of power. The village also had a problem with power at night, which would need another solution. If we were to further explore these topics, this is where we would start. For the confidence in our results, we are decently confident that our solution will improve the quality of life in our village. We won't know how well it will go until it really happens, though. Other key areas for future sustainability. Longevity in our solution is still a major problem. If we were to look for better solutions, this would be one of the key areas we would focus on.